My name is Daniel John, and this is a preliminary design review for the 2014 Outback Challenge Search and Rescue Competition. The Outback Challenge is conducted every 2 years and challenges entrants to design and develop a UAV that can perform autonomous tasks. This video will give a brief overview of the 2014 Outback Challenge and the members of the UQ UAV Team St. Nick involved in the challenge.
An unmanned airborne vehicle, also known as a UAV, is an aircraft that can undertake flight without a human pilot on board. Flight is controlled either autonomously by onboard computers or with remote human control. Many different UAVs exist and can be both used for military and civilian applications.
There are many advantages of using UAVs over manned airplanes. Most importantly, running an unmanned drone costs a lot less than a conventional aircraft, and this makes way for larger and more extensive operations. For example, helicopters can cost up to $600 per hour of flight, so imagine how much more we could get done if all that cost went into unmanned flight. In Australia, UAVs are used for things like surveillance, pipeline observation, and disaster monitoring. Living in one of the world's least densely populated countries, we need all the help we can get.
Rescued from a frightening outback ordeal, Sam Woodhead, the 18-year-old from London, seen here with his mother and sister at last year's Olympics, whose early evening jog on Tuesday evening became a 3-day test of survival. He'd set off from a remote sheep farm in Queensland, where he'd just started working, 80 miles from Longreach, the nearest town. But then he got lost and disorientated, and rather than making his way back to the farm, he kept moving further away. He was spotted by a rescue helicopter, sunburned, dehydrated, and suffering from cuts and abrasions.
The UAV Outback Challenge has been running since 2007. The aim of the challenge is to promote the use of UAVs in civilian applications. Teams are to build a craft under 150 kilograms that is capable of autonomous flight. The craft must be able to locate a person in the outback and deliver a life-saving payload.
Successfully compete in the 2014 UAV Outback Challenge. The project has been designed to take place over a 2-year period as to allow for sufficient time for design and development of a prototype as well as supporting documentation. Therefore, the 2014 UAV project was broken into 2 stages, with the flight platform being developed by this year's UAV design team and the search and guidance systems being developed by next year's 2014 UAV design team. Although these systems will not be finalised within the 2013 project lifecycle, the structural and auxiliary requirements of these systems will be planned for within the 2013 design scope.
The project has been broken down into 5 stages. First of all, we got the project definition and analysis, which includes determining all the regulations of the project and then defining what we need to achieve. We then needed to decide on how we would achieve these goals, and then group roles were assigned. Secondly, we had the design, research and project breakdown stage, which we are currently finishing up. This section included the entire prior art research and any aspects of flight we needed to learn more about. The UAV was then broken down into a number of different areas such as wings, tail design and propeller, and each group member was given a couple of these aspects to research. The third stage was the design initiation. This is where we will start to think about the actual design of our UAV based on our findings from the research phase. Group members will then design parts that they had to research following validation from our group leader. Once the designs have been finalised, we will then start constructing them. This will involve a combination of outsourcing already made components and manufacturing parts from scratch. Finally, the testing phase was chosen to last 2 months because we believe this provides the group with enough time to make suitable changes and adaptations to the design.
As team leader, my primary roles are consistent with that of an organisational figure. It is my role to ensure that the project stays on task and accomplishes all the required goals by the required time. This includes maintaining efficient meetings as the meeting coordinator and efficient workloads as the team manager. In order to achieve this, there are many control systems that we, Team St. Nick, put in place in order to keep the team moving in an efficient way. These include the implementation of scheduled work through the use of Gantt charts and work segregation, which is updated on a weekly basis to make sure that each team member knows exactly what their responsibilities are and when their deliverables are due. This will ensure that the project is completed on time. Key performance indicators have also been employed and developed for each phase of the project. Each of the KPIs have been agreed upon by the group and have been implemented in order to maintain time efficiency within the project and also quality throughout. Each week, each team member is graded on their contributions to the team, communication and quality of work. These KPIs will form the basis for peer assessment throughout the semester. As the project moves into the design phase, my roles will also include Global Design Coordinator and Financial Controller. These include coordinating the design efforts and also keeping the projected cost of development on track. Therefore, any major design changes must be acknowledged by myself and the entire group before they can be approved. I will also be taking on a component section of the UAV, the Electronic and Servo Coordinator, which will maintain throughout the build phase of the project. During the build phase of development, in order to maintain good communication within the budget, I will also be looking after all procurement matters, as to counteract any wasting of resources. Lastly, in the testing phase, I've been nominated as the test pilot. However, this role could change in the future if a more suitable candidate with greater technical skills in flying UAV is found. Until then, I'll be training to undertake the role.
The tasks that I will undertake can be broken down into three main stages: research and design, construction, and testing. In the research and design stage, I will be investigating materials, DC electric, petrol and glow motors, and prop performance and design. This will allow for flight calculations to be made based upon educated assumption of size and performance. Data for different prop and motor combinations will be collected and compared to allow for an optimal power to rate ratio to be determined. This prior art research will allow the team to quickly optimize the airframe design. In the construction stage, I will take a leading role ensuring safety and efficient use of the workshop. I will make sure the team has all required personal protective equipment, such as safety goggles, appropriate footwear and respirators, and have completed appropriate inductions so that team members may safely and efficiently use tools and machinery in the workshop. I'll also be looking after the final development of the wings, glassing and sanding to provide a strong, smooth surface. Finally, in the testing stage, I will be monitoring flight data in real time so that we may improve upon our design. This includes monitoring flight speeds and altitudes, GPS location, and visuals from optical equipment mounted on the UAV.
My primary roles in the group include being second in charge and resource investigating. This has allowed me to have a degree of choice in the direction and pace of the project, as well as obtaining a more in-depth understanding of the development's progress and milestones. The resource investigating started off very broad to allow a wide range of ideas to present themselves to us, but narrowed down after getting the other guys' opinions on certain aspects. So far, during the research phase, I've been in charge of researching current UAVs and certain parts of the craft that are needed for flight. In the research phase specifically, it's been really beneficial to see what already exists, and to employ parts of these current devices to suit our own project scope. It's important to keep an open mind during this phase of the project, because you never know what's out there until you look, and any bias towards any particular ideas will surely act as obstruction. In the up-and-coming design phase, I'll be responsible for designing the fuselage using computer-aided design, and prior to any construction, I'll be performing stress analysis on the fuselage using software which incorporates finite element method. Additionally, the payload delivery device will be my responsibility, and I'll need to choose a design which is extremely reliable. Accordingly, I'll report my findings of these design components to the group, which may or may not require the designs be revised. During the fabrication phase, I'll be constructing the fuselage. I'll need to work in accordance with all the other group members, since the fuselage is the most central part of the craft. Constant communication will be needed to ensure the parts work well together and that minimal mistakes are made. Any compromise in patience or effort will certainly be evident in our final model. And last but not least, the testing phase will require a lot of perseverance and tweaking. I've been assigned as a spotter, which means I'll need to work alongside the occupational health and safety assessment and will need to determine any additional dangers. Such spotting tasks will include finding a suitable location for testing and warning bystanders that our testing is in progress.
My role within the team includes being a research investigator, a wing and tail designer and constructor. Being a researcher allowed me to examine full-scale aircraft to gain a general understanding of attributes needed to enable aircraft flight. I progressed my research into two key flight components, being the wing and tail, as I recognise that these aspects are very important to the aircraft. With this knowledge, I can give a general guidance to the group in terms of aircraft design and requirements. Further research into existing air wing designs will provide design concepts that enables testing to be performed. The use of computational fluid dynamic software allows such testing to be performed on the recommended concepts, as these software provides visual airflow models. Providing these models allows information to be understood by not only myself, but other group members. From the software usage, I'll be able to determine the most appropriate airfoil design for the UAV. Construction of the tail and wing will be managed by myself once the design and materials have been finalised. I will need to work with members constructing the fuselage, considering it is the fixing point for the wing and tail. Quality will need to be ensured when constructing the wing and tail, as mistakes could cause catastrophic failure to the UAV during the testing stage. The testing phase will require monitoring by myself of the UAV during flight to determine whether control changes are required. I will work alongside the health and safety officer to determine any hazards in monitoring the UAV, which, if there are, work to minimise it. Our team, SATNIC, will design and construct a suitable airframe for the UAV in accordance to the specification listed in the 2014 Outback Challenge Brief. The flight platform will be developed with basic flight control facilities at the end of October 2013, as well as supporting documentation. This allows for the 2014 UAV design team to take over the design to develop a guidance system for the UAV to enable success for the Outback Challenge. The UAV constructed for the challenge is hoping to promote UAV design in terms of search and rescue being an option until professional service can be made. This will be greatly beneficial in terms of cost, considering UAVs are lighter than commercial air vehicles and don't require a pilot.
So with a solid structure in place, accompanied by a simplistic set of procedures, the 2013 UAV design team will be able to deliver a platform which can achieve a steady flight by end of October. This in turn will provide an essential starting block for the 2014 UAV design team to conquer the 2014 UAV challenge.